So a radical equation could be something like the square root of x equals 4. To solve that, if we want to isolate the x, we get rid of the square root. By squaring each side, we get that x is 16. This is similar to when we solved absolute value equations, in that to solve this, the first step is to isolate the radical. So we subtract 6 from both sides. We have the square root of x plus 4 equals 1. Square both sides. So now I have x plus 4 equals 1. Subtract 4 from each side, I get that x is -3. So we get that it's -3. Do not immediately say that that's a non-real solution or that it doesn't exist, because we're not taking the square root of -3. We do want to check our answer though. Square root of -3 plus 4 plus 6. -3 plus 4 is 1. So we have the square root of 1 plus 6. And since the square root of 1 is 1, we say that that is 7. So this checks out. Our answer, x equals -3. So we have our rational exponent. That is the radical, so we want to isolate the rational exponent. 6x plus 9 to the 1/3 power equals 3 if we add 5 to each side. You could rewrite that with a radical, and it would be a cubed root, and that's how you know to cube both sides, but I want to raise this to an exponent to make sure that the exponent ends up being 1. So I'm going to cube both sides, because if you have a power to a power, you multiply. What is 1/3 times 3? 1. So now we have 6x plus 9 equals 27. From there, it's very basic. Subtract the 9 from each side. Divide each side by 6. At which point we need to check our answer. If you plug x equals 3 back in, you get 18 plus 27, or plus 9 is 27. 27 to the 1/3 power is 3, and 3 minus 5 is -2, so this works. You read the problems, you determine the variables, and then you write the equation, and here what we have is 1.74 r cubed equals 9. We solve for r by isolating the r first, so we get r cubed is 1.74 over 9. So like I said, it's 9 over 1.74. So then what do we do to get r? Mr. Easley?
We do 9 over 1.74 to the 1/3 power.
That's one way to look at it. We could raise each side to the 1/3 power. So r equals what? When you put that in your calculator, you get 1.73. The units here, inches. We have a radical equation. We're told that the first step is to isolate the radical, which is already done for us here. The next step is to square both sides. So do that. If you square both sides, you get 5x plus 14 equals x squared. Which looks like what type of equation? This is a quadratic equation, so we need to have it set equal to 0. X squared minus 5x minus 14 equals 0. And the best way to solve this quadratic, in my opinion, is to factor it, which means we need two factors of -14 whose sum is -5. -7 and +2. So this factors as x minus 7 times x plus 2 equals 0. The zero product property says if we have two things multiplied together and the product is 0, one of them at least must be 0, which means that x minus 7 could be 0, in which case x is 7, or x plus 2 could be 0, in which case x is negative 2. So we have two options, and we have to check them both. We could have two answers, or only one of these will work, or neither of these could work. Plug in 7. We get the square root of 35 plus 14 equals 7. Is that true? What's 35 plus 14? Square root of 49 is 7, so that one works. Try negative 2. The square root of negative 10 plus 14 equals negative 2. That one is true, because you get the square root of 4 is negative 2, which is true. Negative 2 squared is 4. Both of them should work. When you have multiple radicals, you will only be able to isolate one at a time. When you have one isolated, then square both sides. Now the trouble comes in here because we're going to have that on the left. The right side's easy. Square root of x plus 10 squared is x plus 10. On the left is a binomial. And if you square a binomial, you have to FOIL it. So we're going to get 4 plus 4 root x minus 6 plus x minus 6 equals x plus 10. Because when we do this step, it is 2 plus root x minus 6 times 2 plus root x minus 6. You have to do 2 times 2, 2 times root x times 2, root x times root x. That is how, after combining like terms, we end up here. Combining like terms on the left, I have 4 minus 6, which is negative 2. So I have x minus 2 plus 4 root x minus 6 equals x plus 10. We want to isolate the radical, so subtract this x over, add 2 over, so we have 4 root x minus 6 is 12. Divide each side by that 4, I get root x minus 6 is 3. At that point I square each side. I get that x minus 6 is 9, so x is 15. Now we got to check it. 2 plus the square root of 9, does that equal the square root of 25? Square root of 9 is 3, so 2 plus 3 is 5. Does 5 equal the square root of 25, which is 5? Sure does. So x equals 15 is our answer. Included this problem just to point out to you guys that if you have a rational exponent like this, you want to raise each side to the reciprocal, to the 3 halves here. Hard to see in that color, but that's 3 halves. The reason being, you have x plus 5 to the 2/3 to the 3 halves. 3 halves on each part there. And since you do power to a power is multiplication, that leaves the left side as x plus 5 and the right side as 4 to the 3 halves. Now this could be 8 or negative 8, because you take the square root of 4 to solve the problem. The idea there is, if I tell you that x squared is 9, do you know if I'm looking for x is 3 or x is negative 3? No. So you have to tell me. It could be 3 or it could be negative 3. I don't know which one you want. So up there we have x plus 5 could be 8, or x plus 5 could be negative 8, so x could be negative 13, x could be 3, at which point you have to check each of those possible answers. These should both check out nicely. So x could be 3 or negative 13 there.